Okay guys, today we are going to talk about divisibility rules. Divisibility rules are rules that will help you determine if a number can be evenly divided. And that's really going to help for us because we're going to start moving into prime and composite, and divisibility rules help us identify prime and composite numbers really quickly. So what are the divisibility rules? Well, first of all, we have the divisible by 2. Divisible by 2 is an easy one. That one we just say if the number is even, it is divisible by 2. Now, if we remember from our lessons or from past grades, we know that an even number ends in a 0, 2, 4, 6, or 8. Those are even numbers. Then we have our divisible by 3 rule. How do we know if the number is divisible by 3? Well, I'm going to use the correct definition, and I'm going to use a lot of math words in that definition, so then I'll explain it after I use it. So a number is divisible by 3 if the sum of the digits is divisible by 3. Now, what does that mean? Well, first of all, we know that sum means that we have to add something together, and it says to add the digits. Those are the two numerals that make up a number, or 3 or 4. So the sum of the digits is divisible. That means can be divided by 3. So that's how we know if a number is divisible by 3. The next rule we have is divisible by 5. How do we know if a number is divisible by 5? If the number ends in a 0 or 5. Very easy to do. Now, we have those rules, and I have them down, but let me check a number to see if it's divisible by any of those. So if I took a number like, let's do 14, okay? And I want to see if it's divisible by 2, 3, or 5. Let me go on to the next page so I have more room. Number 14. The work I always want you to show is to write down a divisible by 2, divisible by 3, divisible by 5. Because we're going to check it and see if it's divisible by those numbers. So let's try 2 first. Well, what was the 2 rule? The 2 rule was the number is even. It ends in a 0, 2, 4, 6, or 8. Okay, 14. Is that number even? Yes, because it ends in a 4. So I put a check mark by the 2. Then I go back and I look at my divisible for 3 rule. Divisible by 3 says the sum of the digits is divisible by 3. Sum of the digits. So I take this number 14 and I add the digits. 1 plus 4 is 5. Well, is 5 divisible by 3? No, 3 can't go into 5. 3, 6, 9. No, it does not go into 5. So it is not divisible by 3. And finally, my 5 rule was that the number ends in a 0 or 5. So does 14, my number, end in a 0 or 5? No, it does not. So the only thing that 14 was divisible by out of those 3 rules was divisible by 2. Now, this is really going to come into play later when we move into prime and composite numbers. And here's the reason why. Because when we have a prime number only has 2 factors. Factors are numbers we multiply to get a number. So a prime number only has 2 factors. A composite number, on the other hand, has more than 2 factors. So that's the difference. A prime number has 2, a composite number has more than 2. Now, just about every number has 2 factors. Okay, let's think about the number 2. How can we get the number 2? Well, we can do 2 times 1. Can we do anything else? And I know some of you say, well, we can do 1 times 2. Well, yeah, you can, but just because we switch the factors doesn't change anything. So that doesn't count as an extra set of factors. So 2 times 1 is the only thing we can do to get the number 2. So here's a factor, and here's a factor. That's all the factors that the number 2 has, which is how many? 2. So that would mean that the number 2 is prime. Then we think of a number like 6. We can do 6 times 1. What else can we do? We can do 3 times 2. Anything else? No. So now we look at these factors. We have 1, 2, 3, 4 factors. and that is more than 2, so 6 would be composite. So a prime number only has 2 factors, and a composite number has more than 2. Now that's where your divisibility rules come into play, because every single number is divisible by 1. So every number already has 2 factors. So when we want to figure out if it has more than 2, we can use our divisibility rules. So if we were given a number like 14, and we use our 3 divisibility rules, if 14, we know that 14 already has 14 times 1. We're trying to see if it has anything else. Well, we know that it did not have a 5. We know that it did not have a 3, but it did have 2 times something. So right now, that already means that 14 has more than 2 factors. So what kind of number has more than 2 factors? The kind of number that has more than 2 factors is a composite number. So 14 would be composite. So let's do another number like, let's do 27. No, let's do 29. No, 28. I can't think of any. 27. We'll do 27. 27. Okay, we got our divisible by 2, divisible by 3, divisible by 5. I want to see if 27 is prime or composite. If it's prime, that means it only has 2 factors. So if it's prime, it's not going to match any of these rules. So let's see. The 2 rule. Does that end in a 0, 2, 4, 6, or 8? Nope. 3 rule. Let's add the digits. 2 plus 7 equals 9. Okay, can 3 go into 9? 3, 6, 9. Yep, 3 can go into 9. 5 rule. Does it end in a 0 or 5? Nope. So remember, prime matches no rules. Composite has to match at least 1. Does this one match any rules? Yes, it matches the 3 rule. So the number 27 is composite. Okay, let me do one more. Let's have the number 17. Got my 2 rule, my 3 rule, and my 5 rule. So my 2 rule, it has to be even. Does it end in a 0, 2, 4, 6, or 8? No. 3 rule, I add the digits. 1 plus 7 equals 8. Does 3 go into 8 evenly? 3, 6, 9? Nope. So 3 rules out. 5 rule, does this number end in a 0 or 5? Nope. So you see that it matched no rules. That means for 17, the only factors are 1 and itself. So that means 17 is prime. Now, we talked about prime. We talked about composite. There's one more kind of number, and that is a unique number. And there is only one unique number, and surprisingly enough, it's the number 1. Now, why is the number 1 unique? Because let's list the factors of number 1. Well, it's 1 times 1. Is there any other factors for 1? No. So how many factors is that? Now, some of y'all want to say that's 2 factors, but that's not 2 factors because this number is the same number. So we don't count it twice. So the number 1 only has 1 factor. So a unique number only has 1 factor. And the only unique number is the number 1. Because remember what we said back here. Prime numbers have 2 factors only. Composite numbers have more than 2. And we use our 3 divisibility rules to help us figure out the larger numbers if they or prime or composite. And I'm going to do one more 3-digit number to show you how we can use it there too. Let's do 135. I want to see if it is prime or composite. My 2 rule, does it end in a 0, 2, 4, 6, or 8? Nope, it's not even. 3 rule, let's add the digits. 1 plus 3 plus 5. That's 5, 6, 7, 8, 9. Does 3 go into 9 evenly? 3, 6, 9. Yep. Does it end in a 0 or 5? Yep. So, did that number match any of my 3 rules? Yes, it matched 2 of them. So this number is definitely what? Composite. So that's the difference between prime and composite and the importance of our divisibility rules. There are some other divisibility rules that we'll talk about in class, but for 5th grade, all you really need to have down is the 2, 3, and the 5 rule.